Okay, so this is LeetCode 1379. Find a corresponding node of a binary tree in a clone of that tree. So before I get into the optimal solution here, let's just read through the description. So we're given two binary trees, original and cloned, and given a reference to a node called target, which exists in the original tree. And so the cloned tree is a copy of the original tree. And so what we want to do is return a reference to the same node in the cloned tree. And we should also note that we're not allowed to change any of the two trees, and the answer must be a reference to a node in the cloned tree. So if we go through this example, when our target is the 3 here in the original tree, we want to return a reference to this 3 in the cloned tree. Pretty simple. The rest of the examples are pretty self-explanatory. So if we just go through the constraints as well, so the number of nodes in the tree can be between 1 and 10 to the power of 4, and the values of the nodes are unique, which can help us for a possible solution, but I'll get into that in a minute. And the target node is a node that exists in the original tree and is not null. And this follow-up is also, could you solve the problem if repeated values in the tree are not allowed? So let's just go through a solution. So straight away we can think we have to do some sort of traversal of at least the original one to find the target, and the cloned one as well to find the corresponding target. But just the specifics of that traversal is where sort of the main part of this problem lies, or the solution. So I chose just to do an in-order traversal. You can do any sort of traversal you want. You can do pre-order, post-order. You can even do a BFS on the tree. So I did an in order, so all we want to do for that is just while an in order on the original tree, I should say, and all you do for that is just while the current sort of node is not null pointer, we want to go to the left one, and then we want to sort of process the current node and then go down the right side. And we're also doing this on the cloned tree at the same time. And so we go down the left side and then we go check our current node, and we check that if the current node in the original tree is equal to target, then the answer must be the current node in the cloned tree. Because we can't just go through the cloned route and the cloned tree and just check if each node equals to target, because target only exists in the original tree. We've got a corresponding target in the cloned one, but it's not the exact same node, so we can't directly compare them. A slightly more naive approach that you could sort of do using that idea would be just to traverse down the cloned tree and check if the current node's value is equal to the target's value. You could use that, but that will not work if there are repeated values in the tree and the target is a repeat value. So this just avoids that. We can use this approach when there are repeated values or when there aren't. It doesn't matter. We just want to see that if the current root in the current node in the original tree is equal to our target node, then our answer must be our corresponding cloned tree node. And then all we do is this is just sort of arbitrary specifics, but I just made a class-wide variable just called answer, so we don't have to so we can set answer in this in order traversal function. It just makes it a little bit easier and easy to read as well. So we just set that on order, and as we do that, answer will be set to the cloned corresponding root, and then we just return answer. So if we submit that, we can see how well that actually goes. So, you know, pretty good. Still green. I guess these are just some extra optimizations that maybe you can make, or maybe it's just the LeetCode variants that you sort of always get with these runtime and memory results. So if we just go through the complexity of this solution, so the time complexity will just be big O of n, where n is the number of nodes in each tree, as we just have to iterate down each node once. And since it's a multiple of 2, as we have to do it twice, it's still big O of n. And this checking is constant as well, so it's just big O of n overall in the time complexity. Regarding space complexity, the only thing we're worried about is the height of the stack that we get from these recursive calls, which will just be what's the word? It'll be sort of corresponding to the height of the tree. So big O of n, as well as in the worst case, the height of the tree will be like this example, where it's pretty much a linked list where the height is the same as the number of nodes. So just to recap, the time and space complexity are both equal to big O of n, where n is the number of nodes in the original tree, we can say, as the clone tree is the same, so it doesn't really matter to differentiate between those. If you have any questions or anything about this problem or this solution, feel free to leave them in the comments below, and I'll be sure to get back to you in about 1 or 2 days, I'm happy to say. Yeah, if you enjoyed this video, feel free to leave a like and comment any feedback you have, and definitely subscribe if you'd like more videos like this. Alright, thank you for watching.